What is going on, everybody? Today's video, I'm going to be doing a teardown on a 2015 plus 6-speed WRX transmission. I get a number of inquiries on taking these things apart. People want to know what makes them work, what makes them doesn't work, and kind of what things to look for, I guess, when you're taking them apart to fault find. This one was stuck in gear. So we're going to be finding out possibly why that is happening, and then general disassembly and what to look for once you have it apart. I don't know yet if I'm going to make an assembly video, as I don't think people want to sit there and watch me spray brake cleaner on stuff and assemble it, but there is a chance I will make a couple clips as it goes back together, because I know there is interest in those videos, so we'll see. But on this transmission so far, I've gotten almost all the bolts loosened, so they're all kind of, you're going to notice some of them will rattle, some of them will fall apart. That's just for the sake of anyone watching me do this with headphones. I don't want people getting their ears blasted out by the impact the entire time. Let me know in the comments if you think I should do like a voiceover during these. I feel like it's gonna sound like I won't stop talking if I do some sort of a voiceover, but I don't know. Let me know what you think, or let me know what kind of videos you want to see on this stuff, because I know a lot of people will touch just about anything but a transmission, it seems like. So I know it interests some people, and that's why you're on this channel watching me right now, is just to see what happens inside of these things, or what makes these things work. So I don't know, let me know in the comments. Tip for anyone on these things, there's a lot of, on the 6-speed WRXs, there is 8 or 9 different kinds of bolts that hold these things together and hold brackets on. For ease of remembering where things go, I recommend just putting your bolts back in where they came out. That'll kind of give you a roadmap back to putting it back together. The STIs are a little bit easier. They use 3 primary kinds of bolts if you are not taking internal stuff apart. On the outside of the case, STIs have the 2 different length bolts on the tail housing, and then they have 1 kind of bolt on the main case. So now we have the cables off of this thing. Snake those out. That's I wanted to put that in here because that might cause some issues with people putting them back together, not knowing exactly where the cables go. So I wanted to show taking those off for anyone that was doing it at home. So now we're going to be removing all the bolts. The good thing about Subarus, and the good thing about these transmissions, sorry about that. The good thing about these transmissions is there's really only one place for any of the bolts to go. And the general rule of thumb on Subarus is there's about 10 millimeters of bolt protrusion when you set the bolt in place. So I'll show you just on this one. So this bolt here, it sticks out about 10 millimeters proud of the case here. So that kind of gives you the idea of where it goes. If you put it in the wrong place, it's going to be pretty obvious. You'll have, you know, the full length of the threads, or maybe some of the shank showing on the bolt. So that should be pretty straightforward there. Like I said, I loosened most of the bolts on this thing. Other stuff I just leave these in place. The little wire holders, it kind of gives you an idea of where they go. Also taking a couple general photos from the outside from all directions, that'll save a whole lot of headache generally on these things. I don't discourage anyone from doing this. I don't discourage anyone from doing this in your home garage. I know it's expensive. Anyone that has taken apart an engine can understand how complex certain things mechanically can be. And I urge, if you have the skill to successfully take apart like a Subaru engine and put it back together, I think you have the skill to do transmission stuff. It just takes patience and some care and attention to detail. You'll struggle. There's certain things that people struggle with, and it can just, being patient can be your best ally in that situation. Anytime I ever question myself or question anything that I'm working on, you gotta take a moment, check yourself, so you don't wreck yourself, you know. Even with 6 speeds, there's a handful of small little things that I think people screw up on, or like people don't take the time to figure out how something works, and they may just assemble it how it seems like it would be assembled, and then later on in the assembly they have problems. One of those things I see a lot of, even from shops and professional transmission builder, or like, well, we're going to use that term loosely, but 6 speeds that I've seen torn apart at shops, I've seen a number have issues in certain areas, and it's sort of the fault of the builder, but if given a little bit more time or maybe intuition, like if you had built other ones of these, you would probably catch it or be able to know what to do. I'm not out here talking shit, but there is a spot on the input on the pinion shaft where your pinion shaft goes into the where the pinion goes into the pinion shaft. There's a Torrington bearing on the front of that. If you've ever ordered one of those from Subaru, which if you rebuild more than maybe 5 or 10 of these things, you'll see one that's messed up. Or if you've ever taken one apart that someone else has built, it's kind of a roll of the dice. 25% of them are usually destroyed, and that's usually one of the other things I replace. But if you were paying attention, if you ever replace that, and you look at how the part comes from Subaru, it comes glued together with grease. And that's just an example of, like, you know, if something has to stay together and you question its ability to stay together while you're assembling it, you know, greasing it's going to be your best friend for keeping it together, if that sort of makes sense. I don't know. I'm just kind of rambling. I want to provide information as I disassemble this, because it's like you're going to watch me just take bolts out. It's kind of boring. It's kind of my way to fill the gaps, I guess. You'll see me use the impact to remove the bolts. I like to crack everything loose by hand, just in an effort to not destroy bolts. Ooh, this is, oh, there's a little bit of notchiness there with it getting kind of crappy. It doesn't want to fully return. So this issue, the customer complained that it was like stuck in gear, or it was getting stuck in gear, and then they were kind of fighting it. So in my opinion, before it even comes apart, and kind of the ultimatum I gave the shop was like, hey, we're gonna get this apart and expect that there's gonna be some damage with the forks, because that's kind of what the damage you'll see with people who horse stuff around trying to get it to stay in gear or get into gear. All right, so at this point we have all the external bolts taken out of this, and you'll see my area is still pretty clean. I try to do that so that I don't make a mess and am forced to work within my own mess the entire time. It keeps all my bolts clean, so I don't have to worry about cleaning those. Let me go grab a hammer. another tip. Nothing should need force, or nothing should need to be forced. Ooh, I think my phone might be low on power and I might have a low power notification. Let me make sure I have this still recording so that I'm not recording and talking for no reason. Okay, we are still recording here. Okay, now we're going to disassemble the case. So we'll start by removing our side cover here. Situations where it calls for a screwdriver. Crack that loose. Get it off the dowel pins. That's one thing I like about Subarus is generally they give you places to pry stuff. So this is the cover here. It has a little detent and spring. Watch for that. I'm gonna kind of just let that hang off to the side. The here's that little spring and detent. It fell out. Keep track of that. This guy has to get removed. This is the way this works is you have this selector right here, the top one. This is your side to side on your shifter. And then this one back here is your fore and aft. So some of the issues with these transmissions revolve around this shift shaft hanging up inside of the rail here. So you'll notice some of them have issues in that region. This one I'm actually expecting, just based on the smoothness of travel, I'm expecting the issue to also be further up. There might be some damage in the sliders and or the keys, because it's binding up just like this. With no side to side, trying to select any gears, it would just naturally rest in the 3/4 rail. Even then, it wants to hang up and forth. So I don't see any issue hanging up inside of here, so this isn't going to be my area of concentration with the rebuild. It's going to be further up in here. So with that, we're going to get hopefully we can get this little roll pin out of here. That is bottomed out, so we will have to take the tail housing off of this to get that out. Some of these will come apart without taking the tail housing off. Some of them need the tail housing taken off. When you're taking them apart, focus on where you're hammering as well. You can break stuff pretty quickly. And avoid destructive prying. Some prying on certain things can and will damage it. So do what you can to mitigate that. There, I put the screwdriver in, I set it there, and I hammered on top to sort of pull the bottom out a little bit here so I can get that off of its dowel. All these cases are doweled together. Okay, got the tail housing off. You have your extension housing. There's a bit of metal in there. You'll notice any one of these that has had a hard life, this is where you'll start to see it. Pop the differential out of this thing. Set that aside. If it leak, don't take that apart either. If that has to get taken apart, it's something that you should be realistically sending off to have rebuilt. So we have the diff out. Now we should be able to get this right into the neutral position. That might take a little bit of work. There is a chance I should be able to pop out the roll pin with the diff out of the way. Sometimes you're able to do it, sometimes not. There we go. 16th inch roll pin punch, and then we have the 1/8 inch roll pin punch. Okay. There's those two. Now we got to now we're going to separate off our extension housing because stuff is now freed up to the point that the shift shaft will slide out when you slide this off. So take care of that. This housing is a little bit tougher. I usually like to smack on the mount because that's generally that's a spot where you won't really hurt anything if there's a dent there. This also has a paper gasket in the housing that will need replaced. Another thing with the disassembly, you have to take the rotating pivot off because this guy has to slide out of the way. You have to push this in. It slides out of the way of your main shift rail. If you don't do that, if this thing isn't pushed in, you won't be able to get the tail housing off because the shift shaft will hang up this pivot will hang up the rail from the tail housing coming off. And you might have to give it a little bit of assistance and wiggling some stuff around with that shift selector to get the tail housing off. Generally, it likes to stick in place. And the angle that it is, usually you have to pull it off in the angle that it wants to be pulled off in. It straight up won't come off. If it's possible, the transmission should likely be shifted into 4th gear. That gives you the most, that gives you the least amount of hang up. But usually these things are taken apart because they're stuck in gear, so I get that. Might have to hammer on the shift shaft. It's all come apart. There we go. All right. So this is what you're fighting. This thing has to come forward, and the angle that it is in the case, it goes in at this angle. So you'll have to watch that as it comes apart. Another thing, this, get a towel and clean this. Looking at this is going to kind of show you how hard the customer's been on the shifter. Any deep gouges in this, you know, consider it a wear item if someone's really beating the crap out of it, but you know. It's back together. When you're taking it apart, you have your pivot. This guy, you have to pull it up and out of the way because of the slots. Through the slot that this rides in, you have to move this up and out of the way to release the shift rail. And that up out of the way. Now we're going to take, we had all the external bolts taken out, and then additionally, you're going to want to pull the shift fork out and the throw bearing out because that's going to hold your split case together. You don't have to remove the shift fork, but it's good practice. Check the quality or check how your ball stud looks. your pivot rides on. Now we're going to take out two 12 millimeters in the back here on the main pinion bearing. I'm going to take out all four because I plan on taking the shafts out of this. At this point, there's not a lot of diagnostic you can do. You really have to get the whole thing apart. There's this upper plate. Take that tube off, that out of the way. Verify all your bolts are taken out. At this point, I smack usually on the inside of the bell housing up, so this is gonna make a loud noise. So that is now broken loose. Another thing, if you've ever done a repair sleeve, take that off as well. You will curse yourself trying to get this thing apart. You won't be able to get it apart with a repair sleeve. Holding the snout together. The other place I hit is the dowel on the back. Just give that a couple taps to break the silicone loose. Once you have the bell housing broken loose, they come apart pretty easy. So here's the unveiling the inside. Once we're off the dowels. Okay. Inside here is pretty good. There's a small little bit of metal on some of the stuff in the bottom. That's pretty normal. All right, so we're gonna do our, we'll call it an in-depth failure analysis. We'll just take a look at this thing. I can already see one thing that's messed up in it. But I'm gonna take this out. We're gonna take the input shaft out first. This is also a good spot to like take a picture so you know how stuff goes. This could be marked. You could mark the direction because it goes in only this way. If you put it in upside down, the bolt holes, two of the bolt holes won't line up, but you won't know until you have the case on. So again, marking your stuff. But looking around in here, you can do your quick analysis of how the forks look, how the internal transmission components look. So at this point, you can use a pick tool and you can pry against your synchros and kind of with the, it's like a brake pad. If you're like, you can measure the distance between the backing plate and the rotor, and that will give you your brake pad wear. And then you compare that to a new stock rotor. I don't have the measurements of a new stock synchro. I can give you an arbitrary number. If it is a single piece synchro, it's about 40 thousandths, and if it's a multi-piece synchro, it's about 50 thousandths. It depends on if it's a 1-2 or if it's a third gear one. They vary a little bit. But basically what you're looking at is from the brass on the synchro to the face of the gear, there's a gap there, and you kind of press down or you pry down on it, and you'll know right away if something is worn out. Like if a customer is complaining of a grind, you'll see it bottom out pretty quick. There is the, I'll call them like a phantom grind. There's the issue where if you beat the trash out of a 15 plus transmission or 09 plus transmission, if you beat the crap out of it, sometimes what'll happen is the synchro will smear itself onto the gear itself, and then it will look like the synchro is good, but it won't be. There will be wear, or there will be the brass being deposited on your gear itself will act as a lubricant, as brass is a lubricant. It has a tendency to hold oil, and it has a positive friction coefficient. The carbon ring upgrade is a way of stopping that from happening. Carbon rings and brass rings can both put up with an amount of abuse, but the brass ring kind of will yield, or if you get it hot enough, like if you get the brass ring hot enough and it smears the brass onto the cone of the gear, then you have an issue where you have a lubricant against a lubricant, or brass on brass, and brass on brass is far less effective compared to brass on steel. And that's where you get like, you'll beat the crap out of a car, or you'll do a couple passes and you'll notice like your transmission has a grind, and then that's where like certain fluids that have different friction coefficients or friction modifiers, those will affect the transmission in either a positive or a negative way. And it depends on whether or not the component is worn out or not. That's kind of a lot of information, and that might not be understandable to everybody. That's kind of the way that I see things, and the reason you'll see this one has this blue fluid, that can be a Band-Aid and it can be a fix. So a Band-Aid, it's kind of both. You can fix a grind with the shockproof fluid because it does affect the friction coefficient, but nothing will, you know, there is still the ability to swap out the broken or the damaged component with a better component, being going from a brass synchro to a carbon synchro. And then over time, if it had a grind, over time, it'll get better with the fluid, or as the brass wears off the cone and as the synchro wears more over time, you'll notice it will improve a little bit. So we'll get the shaft out of here. I can already see the fork is fucked up here, but we'll pull this out. So pulling the slider back, this is where you'll be able to kind of see your heights. This customer definitely had a third gear grind. It was reported to me that that was an issue with this transmission, and right away when you put pressure on the synchro, it bottoms out immediately. So, you know, that's a clear indication of it had a problem. Fourth gear, I don't believe there was any report of an issue into fourth, which I would, you know, tend to agree with. The synchro is almost brand new there. With the longer ratio in these transmissions, you see third gear being the problem before you see fourth gear being a problem. Again, and then other things with taking these apart, you might find one of these things, one of these little slugs. These go in the shaft here. These cannot get lost. If this gets lost or disappears, and you bolt it all back together, the bearing can move around. And if the bearing moves around, if it slides out the front or puts an uneven load, it will pretty quickly destroy your case, and it will pretty quickly destroy anything related to that component. Like it'll destroy the case here, destroy the bearing. You will then lose your input shaft stability here, which in theory wouldn't be a problem because you have your pilot bearing, but again, it would put undue, your strain on your input shaft goes from being from here to here, and then here to here, to from here all the way to the front, which these transmissions already have issues blowing the gears out because of deflection inside of the transmission. You don't want to add to it if you can help it. These tend to hold a little bit more power. I believe they changed the little bit of the metallurgy, and the shafts are a little bit stouter. Sorry about the noise. You can see right away we have a broken fork right here. It is missing both the pads and the fork is snapped. And then we will check our synchros here. I was not told that there was any other grinds other than third, and I believe that is the case. We may put a second gear synchro in it just as a precautionary thing. That's the technically second most shifted into gear. It's second, third, because you go into those gears going up and down. Additionally, here's that piece of that fork. It's floating around. So here that is, snapped off. So this definitely explains to me why it didn't want to move in the third to fourth area, or between the 3-4. It didn't want to move because you have kind of a side load. It would probably shift okay while it was in gear. The problem mainly being is you beat the crap out of it, you weaken it, you weaken the pad surface, you weaken the fork overall by beating it up and forcing it. And in the process of beating up things and forcing them, you'll find that you'll weaken things and you'll snap something like this, where this is the weak point of this. And then after this snaps, it may not be, you'll notice more slop in that gate. So in up and down play in the third gear, you'll notice the shifter has more slop before it feels like it's mechanically doing anything. Additionally, this piece will disappear. You'll notice primarily, or one of the biggest, most obvious things about a damaged fork is it will behave, the shifter will behave worse with the car off. Because you're now only applying pressure to the slider from this point right here, it is heavily side loading the slider, and when you heavily side load it, it doesn't want to move as much unless it's in motion. So if it's spinning, this will do a better job of trying to get it into gear. And that's also the case if you have the clutch in and the car is at a stop. So if the car is rolling, I bet this transmission didn't really have a problem going third to fourth. It may have in the end because of all of the damage like accumulated, but third to fourth was probably okay while the car was rolling. But anytime the clutch was in and the car was stopped, I imagine it was a little tough to get into third or fourth. And then outside of that, I don't see really anything else wrong. There wasn't much of a complaint other than the 3.4 and it getting stuck, which now you guys and me can all see where the source of that is from. Here's a broken piece of metal. In any transmission you take apart, look for any pieces of metal, because you know, if you can guarantee that it had never been apart before, there's no reason for any foreign contaminant to be in the transmission unless it was put in with the oil change, and generally that doesn't really happen. So looking for any pieces of metal and finding their source is very important. Metal in these transmissions can come from a lot of different places. The shimmery non-magnetic stuff you see in the oil is primarily from the synchros, and then any contaminant on the magnet would be from a hard part failure or a hard part wear. So if you take a magnet out and you rub that what's on the magnet between your fingers, if it's silky smooth, that's general wear from the hypoid gears and the speed gears inside of the transmission. If it's gritty and feels like sand between your fingers, or there's any sharpness, that is a sign that you're wearing, generally it's a sign that you're wearing the engaging teeth. And if there is mass accumulation of metal and you see little flakes on the magnet, that's generally a sign of a bearing failure. So you can kind of determine all the different failure modes of one of these transmissions just by how the magnet looks. If the oil is very dark and very shimmery, but not a lot sticks to the magnet, that's a time that you should go through your center differential or make sure that your center differential is intact. A lot of times, if you have a failed center differential, for example, if the vehicle gets towed improperly, here's a damaged, oh, look at that, sharp. If a center differential gets damaged, there's like, it acts like a piston if it ever overheats, where if you flat tow or if you tow the vehicle improperly, it'll heat this up and you have a viscous in this section here, and it's sealed on the front and the back. And generally the snap ring will blow out of the back and it will get fed through the transfer gears. Alternatively, like on this transmission, it blew out the front, and when it blew out the front, it absolutely obliterated the spider gears in here. And those have to work really hard themselves as well when you have differences in wheel speed. So you'll see damage in both the spider gears, the spider gear cage, and the snap ring, and potentially blowing the snap ring out of the back. So that's just for WRX stuff. I have a snap ring right here. This was kind of pried out, but you can see it's bent pretty horribly, and the ends of it should look like this, or you have the one-piece snap ring, not the spiral lock. But you can see how this edge does not look the same as this edge and how it is bent. That was not from removal, that was from just the amount of pressure being applied by the viscous overheating. So it's like a pressure cooker. Everything inside will be destroyed and welded, and if you get into a situation like that, you know, there's a lot that has to be gone through. Some of them are savable, like this one, how you can see that the snap ring is partially damaged. This one wasn't ruined, but it was very close to being ruined. And in that transmission, the drop gear, the transfer gear, and all but one of the bearings was salvageable. And the bearing that was bad was the front one on the center differential, the one that goes right here. So in some instances, you can save it if you know it happened. You can save yourself money by fixing it right away. If you can find a core, generally all 5 speeds have the same center differential. When I'm talking like 02 to 20, like the 15 was the first of the 6MT 5-speed, or 6MT split case. So anything 02 to 14, they're all compatible. They're all the same as far as I know. They all have the same viscous weight, and the splines are all identical between all those. But anyway, I don't want to make this too much of a ramble video, but I'm just giving as much data and stuff for you to look at in your own transmissions and in your own travels, just stuff to look at. Additionally, just right here, I want to show you some more damage that I just spotted. So as you can see, this fork is hammered. The pads are ruined on this as well. They're not ruined, but they are damaged to the point that I don't want to reuse this or go back together with this. So anyway, that's everything in this transmission. I hope this helped. I might do a general video going back together, but your factory service manual will tell you a lot of going back together in this stuff. There's a lot of stuff that's important in there, and then there is a lot of stuff that is not important in there. Everybody says that you have to have every single factory special tool to do these. I disagree with that statement. You can do a lot of this in your home garage, similar to how I do. I have some of the Subaru OEM tools, not all, and I don't deem all of them necessary, especially if you're just doing a mild repair on a fork or a mild repair on like a synchro. There is things to watch out for when you're doing fork replacements. Many times in 5-speeds, the forks will have part revisions over time. So these forks are marked with a number, and that number right here is on the front of the fork facing the engine. So this fork here has a 07 on it. So when I go to replace this, I want to replace this with an 07 fork. That's just an arbitrary number, but that's the designation for that fork. And likely that has something to do with the distance and the heights. Also in this application, I'm going to consider replacing the 3/4 fork here. Taking a look at the engaging teeth here, these should look very happy. These should look, they're shaped like a house, and the more a transmission grinds over time, the more of the top of the roof it will shave off, and it'll slowly work its way until you're just grinding on a square shape. Over time, it's both in here they're that shape, and then on here they're that shape. If that wears over time, sometimes a synchro is not always the solution to fixing a problem. You can have a pretty hammered engaging teeth and put a synchro in it, and it will help. But the downside of that being damaged and you only replacing that is sometimes the transmission will lock out. It will, you'll go to shift into the next gear and it will hit a wall, and then it won't sink into gear until you have the clutch, like until you're releasing the clutch. So sometimes it'll hit a wall, and that's those two now misshapen surfaces smacking into each other and kind of resisting the sinking into gear. So it's like this, and then sometimes that'll be a problem, and then sometimes it'll go into gear no problem. So that's kind of what your how some of this stuff works. In these transmissions specifically, the fork damage is pretty, that seems like something that happens quite a bit. And then generally third gear for some reason seems to be the synchro of choice for wear in these things. So in this application, I will be replacing the third gear synchro, and in depth, I will, when I press everything off the shaft, I'll take a look at everything and kind of go from there as far as what I replace. But thank you all for watching. I hope this helped somebody out there be able to diagnose their transmission. If you run into a situation where you replace anything on this shaft, you're gonna need a very specific socket. I have a socket that I cut and welded with a tube to be able to get down this. I don't care how deep your sockets are. It's gonna be like a 4-inch deep socket to be able to get that off. So you'll notice that in your home experience with rebuilding stuff. But anyways, guys, I appreciate you guys for watching. Thank you. And then maybe I'll pull down the phone and give you guys a little bit better example. All right. Those are those engaging teeth right there. And you see how that flattens out? That's completely trashed. But anyway, as these get wore out, you'll notice the transmission will get harder and harder to get into gear. And if you have a grind over time, that's kind of something you want to avoid, that gear, because that's the wear you're causing when it does grind. So anyways, guys, thank you for watching. I'll see y'all in the next one. I'm tempted to do a 5-speed general disassembly coming up soon. I have a 14 that would be a good candidate for teardown. I have absolutely no idea what's wrong with it, so you can kind of come on that adventure with me and we can kind of find out what's wrong with it. Anyways, later.